all, this is Professor Vishwajit Ambade from Mechanical Engineering Department, and today's topic is manometer, pressure measurement by using manometer. So first of all, let us know what is manometer. Manometer is a device which is used to measure the pressure, by equating or by balancing the liquid column on a limb. Okay, so manometer, there are different types of manometer. First we will consider a simple U-tube manometer. So U-tube manometer consists of one limb, consists of two limbs. So this is the type of manometer. This is the simple U-tube manometer, consists of two limbs. This is left limb, this is right limb, and this U-tube manometer contains the two different types of liquid, out of which one liquid must be heavier liquid than the liquid whose pressure is to be measured, This is another type of liquid. Whose pressure is to be measured. This liquid is of low density or low specific gravity, and this liquid is having more density or more specific gravity than this liquid. So suppose this is P, the pressure which is to be measured with the help of U-tube manometer. This is the height of the liquid. Above the datum line on left limb. This is the height of heavier liquid above the datum on right limb, that is H2. Now let us consider rho 1 be the density of light liquid on left limb, H1 be the height of again light liquid on left limb. Similarly, consider rho 2 be the density of heavy liquid on right limb. Similarly, H2 be the height of heavy liquid on right limb above datum. So the U-tube manometer works on the principle of balancing the pressure on both the limbs. So we will consider the pressure on left limb above datum, which is equals to, तो इसमें हम कैसे कैलकुलेट करेंगे प्रेशर? दिस इज द प्रेशर P unknown, this is the left limb, this is right limb. So we will consider the left limb above the datum. So this is P, pressure is unknown as it is, plus into G into H1. H1 is the height of liquid whose pressure is to be measured above the datum. Equation number 1. Similarly, pressure on right limb above the datum, which is equals to, so what is on right limb? There is a heavier liquid on right limb, so density of heavier liquid is ρ2 into G into height of that particular liquid above the datum is H2. This is H2. Now equating, this is equation number 2. Now equating equation 1 and 2. Equation 1 and 2. So P plus ρ1 G H1 is equals to ρ2 G H2. Therefore, we can say that P is equals to ρ2 G H2 minus ρ1 G H1. So by using this equation, we can calculate the pressure which is been acting on the left limb by using this equation, that is P is equals to ρ2 G H2 minus ρ1 G H1. Now another arrangement is for the vacuum pressure, or we can say that negative pressure. So I am drawing another arrangement of U-tube manometer. Suppose this is light liquid whose pressure is to be measured, is placed on left limb. And another liquid which is present on the U-tube is heavier than the liquid whose pressure is to be measured. Now this is the height of heavier liquid H2 and this is the height of light liquid H1. Light liquid H1 and this is the pressure, unknown pressure. So as we can see that there is a two liquid on left limb only. Therefore we consider density of a light liquid on left limb, similarly height of light liquid on left limb, similarly this is the density on light limb and this is the density of heavier liquid on left limb, not right. Left above the datum. So again by using the same equation, pressure on the left limb above the datum. So as we can see that there is a two liquid on the left limb and there is no liquid on the right limb. So this will not be in consideration. So how we can write the equation to calculate the pressure in such cases? So P is unknown plus this is the light liquid in the left limb and this is the height of light liquid above the datum. So again ρ1 G H1. Okay. Now again we can see that there is another liquid of heavier density P. Rho to be the density of heavy liquid into G into H2 is equals to 0. Is equals to 0. Therefore, the equation to calculate the vacuum pressure or negative pressure is P is equals to minus rho 2 G H2 plus rho 1 G H1 be the equation to calculate the negative pressure or vacuum pressure for such type of arrangement in which both the liquids are present in the left limb. Okay. So we solve the numerical based on YouTube manometer or simple YouTube manometer. So this is numerical number 1. I am detecting a numerical based on the simple YouTube manometer. So this is the arrangement given to us. A simple YouTube manometer consists of the light liquid and heavier liquid. The distance of heavier liquid from above the datum is 20 cm, whereas the center of this left limb and the difference of the mercury level, or we can say that the heavier liquid, is 12 cm. And what we have to find? The pressure which is being acting on this particular liquid. We are provided with the specific gravity of the light liquid is 0.9. Specific gravity of the light liquid means this liquid, the specific gravity for this liquid is given to us is 0.9, and such type of arrangement is given to us. To find what we have to find? Pressure which is being acting on this particular point. So, solution. As the specific gravity is given to us, therefore density of the light liquid is 0.9 into 1000, that is 900 kg per meter cube. Now, as this is mercury, therefore the density for the mercury is 13.6 into 1000, that is 13600 kg per meter cube. Now again, H1. What is the H1? H1 will be this distance, but this is not given to us. We have to calculate. So total distance, this much distance is how much? 20 centimeter, and this much distance is 12 centimeter. So remaining distance is H1. Therefore H1 will be what? 20 minus 12, that is 8 centimeter, means 0.08 meter. So this is the value of H1. Now what is H2? H2 is given to us, that is 20 centimeter, means 0.2 meter H2. Now हमारे पास में density of light liquid, density of heavy liquid, height of light liquid and height of heavy liquid. So therefore, equating the pressure on both limbs will be, तो पहले हम लेफ्ट लिम्ब कंसीडर करेंगे, P unknown plus ρ1 G H1 is equals to ρ2 G H2. This is the equation. Therefore P is equals to ρ2 G H2 minus ρ1 G H1. Now after putting all the values in this equation, what is the value of ρ2? 13600 into 9.81 into height of 0.2 meter minus ρ1, density of light liquid is 900 into 9.81 into 0.08. After calculating this, we will get the value of pressure 25977 Newton per meter square. So in this way we can calculate the pressure which is being acting on the U-tube manometer. Now another numerical, we will take another one for calculating the negative pressure. We will take another arrangement. This is H1 and this is H2. So data given, I am writing what is given on the numerical. So H1 is equals to 15 centimeter is given to us, and H2 is 40 centimeter given to us, and specific gravity of light liquid is 0.8. Specific gravity of the light liquid is 0.8, and this is mercury, heavier liquid. To find again pressure, we have to find pressure. So we will start with the solution. So directly I am writing equating the pressure, on both limbs. So we can see there are two liquids on the left limb. So again we write the equation P plus ρ1 G H1 for the light liquid. This is the height of light liquid. Again plus ρ2 G H2 is equals to 0. Why 0? Because there is no liquid present on the right side of the limb. Therefore P is equals to minus rho 2 g h2 plus rho 1 g h1. Now after putting all the values in the above equation, we'll get what is the value of rho 2. Rho 2 means what? Mercury. The density for mercury is 13600 into 9.81 into H2. H2 is given to us 40 centimeter. We'll convert it to meter, that is 0.4 meter, and this is again 0.15 meter. So this is 0.4 meter plus rho 1. Rho 1 means density. This is 800 into 9.81 into H1 is 0.15 meter. So after calculating the above value, we get minus 3.6 Newton per meter square. So negative sign indicates there is a vacuum. Negative sign indicates this is the vacuum pressure. So hope आप लोगों को समझ में आया होगा. This is all for the today's class.